It's like I don't care about nothing, man. Yeah. Oh,
Okay, so this video is going to be about points of concurrency. Now, it's going to be a short video, but what you're going to want to do is pause the video so you can write down everything that's on here. I'm just going to show everything you need to know about Circumcenter, In-Center, Centroid, and Orthocenter. And then I'm just going to talk over it. So the video will probably be pretty short, but in order to be able to write everything down, you want to pause it and listen to what I have to say. So, like I said in the intro, there's a lot down here, but you're going to want to probably pause it and go ahead and write it, then listen. But first one I'll go through is Circumcenter. Circumcenter is created by a perpendicular bisector. So perpendicular means the lines meet, make a right angle. Bisector means that the sides got cut in half. So perpendicular, 90-degree angle, and every single side got cut in half. So it says the circumcenter is equidistant from each vertex of the triangle. So let's say from A to where the circumcenter is, that should be the same length as from B to M, which is also the same length as C to M. So with this one, a circle can actually be drawn outside of the triangle, and this is called circumscribed. So each of the ones that I just said were congruent earlier could be considered radii, which is the plural for a radius. So AM, BM, and CM would all be the same length. The next one is in-center. In-center is created by angle bisectors. So each of the angles get cut in half. So bisector means cut in half. So it says the in-center is equidistant from each side of the triangle. So each of these from the in-center to the sides, the lines that are going there, will all be the exact same distance. Now for this one, instead of the circle being drawn outside, it's drawn inside, and it can be called inscribed circle. So when we have this inscribed circle, those lines that went from the in-center to the sides would be the radii for this one. So XM, YM, and ZM would all be the same length. The last one that will be tested on is centroid. Centroids are created by medians. Now, median means middle. You notice that each of the sides got cut in half. What makes this different from circumcenter is the fact that we do not have any right angles. Now, a centroid is created by a vertex connected to the midpoint of the opposite side. So, a centroid can also be called the center of gravity or the balancing point. So, where does it balance? A centroid will be 2/3 of the length from the vertex to the midpoint. So, in essence, broken up into thirds, from the vertex to the centroid is 2/3 of the line. The rest would be 1/3. And then orthocenter, there's nothing special about it except that it's created by altitudes. And an altitude must make a right angle. So that's the only thing I expect you to know for orthocenter. When you're studying, these are the three you're going to study. So that's the end of this video. Now, the main thing I want you to get from this is what each of them are created by. Now, for us personally in my class, we're only going to really actually be tested on circumcenter, in-center, and centroid. But with orthocenter, I just want you to know what an altitude is, where you have that line that makes a right angle, because we will be using that word a lot more later on in this year.